Professor Moleff here, and today we are going to go over compound annual growth rates, or what we call CAGR, C-A-G-R. And what CAGR is a way to measure the annual growth of an investment or a value over time. Okay? And there's two ways that we do this. We can use what's called the CAGR formula, C-A-G-R formula, and there's a couple different ways to calculate that mathematically. I have that down here. And I would first like to thank Professor David Benson for bringing us this assignment. And this is two different ways mathematically that you can figure out the compound annual growth rate of an investment or any value. And you can even do it for like the inflation rate, figure out what the inflation rate has been over the last several years. Okay. So we have what's called the mathematical formula, which is the CAGR formula or the growth rate formula. And we also have the Excel function RRI, which is rate of return on investment. So these are the two ways that we're going to figure up what the growth rate is, the compounded annual growth rate for an investment or for market share or anything like that. Now, what we have here is when calculating growth rates, just averaging each year's growth rate usually ignores the effect of compounding. Okay, and what the CAGR formula does and the RRI function do is they take into account the effect of compounding. So I want to go over a little bit with you before we get into our assignment. This is our assignment over here. This is what we'll be filling out today. Go back here to our CAGR tab, and I want to show you this. So we're going to look at sales for Adidas. And so in year one, they had phenomenal growth rate for this, which was 51.96%. In year two, they had a growth rate of 2.13%. In year three, it was 4.85%. And in the fourth year, they lost 3.87%. So what was the average annual growth rate for Adidas during these 4-year time period? And this is a mistake that some people make, is we'll go over here and we'll look at the growth period, 51%, 2.13%, 4.85%, and 3.87%. And if we come here and just decide that we want to take an average, and we average these numbers, we see that it says we average 13.77%. But this actually overstates what really happened, and it also doesn't take into account any of the compounding effect on this. So the formulas that we use for this is the CAGR formula, C-A-G-R formula, okay, or the RRI function. And we can see here that this was the actual return. So this is not the correct year. This assignment's been modified a little bit for academic integrity from previous year's assignments. So these are just assumption years. So using the year 2020, which is year zero, which is, let's say we made a $10,000 investment into Adidas, and then next year our $10,000 grew to $15,196 for a 51% return. And then the next year we added 2.13% to the existing amount. This is our compound growth. And then the next year, 4.85%. And then when we lost 3.87%, it wasn't a loss on this 10,000, it was a loss against this 16,272. So this is the compound annual growth rate. And one of the things that we have in here is, we'll talk about this here more in a minute. So we have these years, year zero, this is the year we start, and these are growth years or periods. And we'll talk a little bit more about that. And this was the percentage of growth. Now I've shown you this as a decimal, and we can take this 10,000 as an example, equals 10,000, or just point to this, equal 10,000 times, we can multiply that by our growth rate, and see we made $5,196 in profit. But that's not our account value. So our account value is we equals this 5,000 plus our original investment, and our account value is 15,196. An easy way to do that is to take our growth percentage, make it a decimal, and then add 1 to it. So this is 1 plus that. And so when we multiply it, and I'll show you, equals our 10,000 times our 1.51 here. And it's giving me these hashtags. By the way, if you get this, this is a good thing to show. All that means is that there's more information in this cell, in the width of this cell, than the current cell width. So I can just come up here to E and just make it a little bit bigger, and you can see that it wasn't an error. It was just showing us that there's more data in this cell than what we're showing. And this is usually around numerical numbers. Okay, it doesn't happen with just plain text, but it does happen with numerical numbers. So if you ever get that, you know what's going on, just make your column a little bit wider. And so that's why we add this 1 here, so when we're multiplying. So to get this number right here, we would multiply the 15,196 times 1.0213, and we get this number. Okay, and so that's how we do it. And we just come through here, we can see that. And you can also see that this negative 3.8, if we add a 1 to it, we get 0.96, because we take that and multiply it by this, and that shows the negative effect of the compounding. Okay. Now what happens is, let's go ahead and use these formulas here to see what the real effect was, okay, of these. We see that this was, we just averaged these values right here, and this is overstating what the annual growth rate really is. So we're going to go ahead and use the CAGR formula. We'll come in here and use the CAGR formula. So equals, and our formula is 2 parentheses, and it is our ending value. So right here, our ending value. So our ending value up here, our ending value, 15,000, divided by our beginning value, this 10,000. And it says to the power of, okay, or the square root of, the power of, which is this caret symbol above your 6, which is shift 6. You get that caret symbol. And then to the power of 1 divided by the number of periods, NPER, or N. You can see up there on the CAGR formula, 1 divided by N. What's very important about that is we have to be able to calculate the number of growth periods. Now, the number of growth periods is not the number of years. So we take a look at this. We have years starting in year 2020 and going through 2024. That's 5 years, but it's actually 4 growth periods. From year 0 to year 1, year 1 to year 2, year 2 to 3, and 3 to 4 is actually 4 growth periods. So it's not 5 years, it's 4 number of periods. Okay, and then our double quote and -1. And we see that it is 0.118349, which is 11.883%. And notice that is very much different from this 13.77%. Okay. And then what we want to do here is we'll add a 1. So equals 1 plus our decimal here. Okay. So this is our compounding rate. And so if we want to see it, now what happens is this assumes a straight line, where we know that growth and investments don't always assume a straight line. We have like 51%, 2, 4, and -3. But this assumes a straight linear growth, but it does take into account all the compound effects. So we'll see if it's correct. This equals our 10,000 times our 1.18, and I'm going to lock that cell. Okay, so it will always point back to it, return, and see in a linear growth, it shows that we have 11,183 versus the 15,000 here. But if we bring this down, we see that these two numbers exist. So this is just showing a linear rate, but it is correct. Okay? So it is showing the compound annual growth rate over the last 5 years that has 4 growth periods, because in year 0 is when we put our investment in. So we always have to start with a starting number. Okay, we have to have a starting value and then our ending value. And if we wanted to do this with the RRI formula, it's equals RRI. And again, RRI stands for the rate of return on investment. So it's equal RRI. We grab that function, and it's saying NPER, which is number of periods. So down here, number of periods. And our number of periods is 4. Okay, not number of years, number of growth periods. Our present value, that the money we started with, is this 10,000. And our future value, or what we ended with, is this 15,000. And we can close this up and hit enter, and notice it's the exact same number. Okay. So now let's go ahead and get started on the assignment. Go over here to our student tab, and let's bring this up. So the very first thing here we'll do is under student name, let's go ahead and put in our name. And this came from Collision Week in 2019, and they were showing the top auto insurers by rank and market share. And this is actually something that businesses look at all the time. They look at what their market share is in their industry, and also whether they're growing or dying, or somebody else is taking market share away from them. As an example, in the United States, the market share is pretty constant. We have, people that turn 16 and go and get their driver's license, and then they have to get automobile insurance, and there's only so much market. So for you to gain market share, it means that you are usually taking clients from somebody else. And how do you do that? It's based on how good your marketing is, your pricing is, and other things. And so these companies are constantly looking at what their market share is. Are they growing? Are they dying? Or those type of things. And that's what we're going to look at here. So we're going to take a look at what their market share is. We're going to use a few other things, some conditional formatting. We're going to look at data bars. We're going to bring in Sparklines, which is a graph that will exist just inside a single cell. We're going to figure out their compounded annual growth rate manually using our formula here. We'll also use our function, our RRI function. We're going to then look at a graph and see if they're gaining or losing market share. Then we're going to run it mathematically as a linear operation, and we're going to see if our 2018 numbers here equal our 2018 numbers here, and we'll do that by seeing if there's a difference. Then we're going to look at running both the CAGR formula and the RRI function using Adidas and Google. And then on your own, and I'll explain this later, we will do this, or you will do it on your own, but I'll explain it in a little bit. So let's take a look at their market share for 2018. And what we're going to do is we'll just copy. I'm just going to equal this information here. Now we could copy this entire thing and then paste it over here. Or I'm going to do equals D5, and then I'll just double click and copy it down. Okay, right here. And so we see we have the same information here. Now what we're going to do is we'll highlight this information. We're going to go to conditional formatting up here in the middle. I'm going to come here to data bars. And now if we just went in, and if I chose this blue or this red, we're going to choose this blue, and I just clicked on it. Notice that we have this blue and with numerical text behind it. I don't like the way this looks because I have this information here, and this is sometimes hard to see or read. So we'll do conditional formatting, data bars, but we're going to click on more rules. And inside more rules, what we're going to do is just click show data bar only. Works the same way on a Mac and a PC, and click OK. And now you see that we have this nice graph inside the cells. And you notice too that under column E, there in data bars, that first one, that 17.05, which is State Farm's percent of total market share, and the top 10 companies have a total market share of 72.17%, that this data bar takes up the entire cell. So how Excel does this is whatever is the highest number gets 100% of the cell, and then all these other numbers are based off of their relationship to this 17.05. So if I were to go here and do progressive here and make progressive 21.02% of the market share, you'll see that its data bar now covers the entire cell, and we can see the relationship to the others. Now I'm just going to do Command Z or Control Z, back that out to where we are, so we can see the data bars in here. Okay. Another way to show this is what's called Sparklines. And this shows us a graph of what's going on as a line graph. And we can see it going up or down. And for this, we're going to go all the way back to using to the year 2000, where we see what their market share percentage was in the year 2000. And we're going to compare that to their market share percentage in 2018. And we can actually see some impressive growth by Geico and Progressive between those. Geico has done a very good job with their Gecko in showing what they can do with marketing. And Progressive's done a very good job in their marketing, but also in their risk scores and how they do it. They use a lot of data analytics to determine who they can insure. So we're going to do a graph of what that looks like. So we'll come here to Sparklines, and we're not going to use the equals. We're going to come up here and do Insert, and we have our charts right here. And we go to the right of recommended charts, both on a PC and a Mac, we'll find Sparklines. And we'll just click it and choose Line. And it's now asking for our data range. Okay, so select our data range, and we're going to do all of 2000 to 2018. And it says where to place it, and it's already there in 05. And click OK, and it shows a Sparkline that it started, it went up and came down just a little bit from 17.9% of the market share to 17.05. Now with Sparklines, one of the things we can't do is we can't just double click and it'll fill down. But if we want to fill it down, we'll have to grab it and drag it down. And so we can see the winners, we can see the losers really quick in a graphical representation. We can also change the colors of the Sparkline. Notice that when I click on any of the Sparklines, we have the new button up here at the top, Sparkline, and I can choose a different color for our Sparklines. If we wanted red, we can do that in red. Okay. Now, if we wanted to delete a Sparkline, I just can't come here, click on the cell and click delete. We'd have to right click, and we can clear contents, go to Sparkline, we can ungroup them, clear selected or clear selected Sparkline groups, or edit some of the information here. But for now, for the assignment, I'm just going to go ahead and leave this in red. So we have this in blue, this in red. Now, for the next part of this assignment, we're going to figure out the compound annual growth rate over the last 5 years. So we're going to start with 2014 and go through 2018. That's a 5-year period of time. Okay. So we're going to do this. We're going to do the formula using the CAGR formula. Then we're going to use the RRI formula or function. And then we're going to actually put in a graph and see who the winners and losers have been. So for doing this formula, it's equals, double parentheses. If you can see up there, we have double parentheses. We have our ending value, which is this 1705, divided by our beginning value, 1807. Close the parentheses, then to the power of, which is shift 6, that little caret above the 6. Okay. 1 divided by number of periods. Now we have 5 years, but we only have 4 growth periods. Now we show more, but we're talking about going from 2014 to 2018. So 2014 is the beginning number. From 2014 to 2015 is 1 period. From 2015 to 2016, second period. 2016 to 2017, third period, and then the fourth period. So for number of periods, we have to have 5 years to get 4 periods. And this is a mistake that a lot of people make and a lot of students make. And we'll close that out and then minus 1. And we can see that our growth rate here is negative 2.28%. And I've already formatted this as a percentage for you, so you don't need to worry about that. And we can just drag this down. Okay. And we can see what each of these are. We can see that State Farm from 2014 to 2018 lost 2% of the market share. Geico and Progressive actually gained pretty good market share. We see that Nationwide lost quite a bit of market share. Travelers went up. Now we're going to do the same thing using the RRI formula, equals RRI, and we'll bring that function in. It's going to ask us number of periods, that is 4. It's going to ask us PV, our present value, which is our beginning value or our starting value, this 18.7, comma, and our future value or our ending value, the 1705, and close that out. And we see that if we did it right, we should have the exact same percentage on all of these. Okay, now we're going to do a win-loss. We're going to see who won and who lost, and we're going to do this in a graphic function so we can see this visually. So we're just going to equals this, and I'll copy that down. And then while it's highlighted, I'm going to go to conditional formatting. I'm going to choose data bars. I'm going to choose more rules. And in this case, I'm going to show data bar only because I don't need to know. I don't want the text behind there. And right now we have this set as positive values are blue, negative values are red. And we're going to click OK. And just now we can see the winners and the losers, where we have this line going down the middle, and we have 2 big winners here, Geico Progressive, a big loser here, Nationwide. But it's a nice, easy way visually to see a representation instead of trying to read all of these. We can just look really quick, and wow, we can see the differences. We can see who the winners and losers are. Now what we're going to do is we're going to check it manually. We're going to do here, like I showed you here on this sheet, we're going to do the linear growth rate on these. Okay, so it's going to be a straight line showing it, but the ending number should equal. Okay. Now, why do we do this? Well, a lot of times if I'm trying to graph into the future or make a prediction or show what it's done, it's very hard to go in and show all of this unless we have the data to show what it may look like. A lot of times when we graph into the future, we don't graph as a variable line. We usually graph as a straight line. So that's what we're going to do here. So we're going to take this data from 2014, Command or Control C, come over here, Command or Control V. So that's the market share we started with. Okay. And now what we'll do is we will multiply this by our growth rate each year. And I'll give us the formula there to do that on there to make sure that we are doing it right. So it's equals, so this is what we started with, 18.7. And we're going to multiply that times. Now what we didn't do is we just can't multiply it by this negative 2.28. Like we did before, we need to multiply it by the 1 plus this number. Now, in other things that we've already done, we know if we fill down or we fill across, we want to go back and always point to this number that we're using here, this negative 2.28%. And in this case, we want to lock in the column. So if we move to the right, it always goes back to that column. And if we move down, it stays in that column. And to do that, we're going to lock in our column cell. And on a PC, that's F4. On a Mac is Command T. If you do it once, notice it locks both the column and the row. If you do it again, it locks just the row. If you do it again, it locks the column. So we want to lock in the column, put our $ before the R, close this formula up. And the reason why is this allows me to just drag over to the right. And while that's highlighted, I'll show you this. I can just drag it all the way down, and it has filled in our information. Now, we look at here and we see this 2018 at 17.05, and this is 17.1. If we extend the number of decimals out, if we increase our decimals, we see that that's 1705. Okay, so don't freak out a little bit if this is only showing a single decimal and this is showing 2 decimals. But we want to see if we did this right. So the difference should be 0. So equals this 1705, which is in Y5, minus, come back here, this 2018, this 1705, and our difference is 0. And I can copy down, and we can see that we have no data in there, so it was done correctly. So this is the actual market share, both going up and down. What we did is we manually looked at it as a compounding annual rate, average marked out, and this is a linear straight line showing that, which doesn't happen in reality, but mathematically this is how we would show it. And then if we wanted to project in the future, if they maintain that same average rate, we can project into the future what would happen, either decreasing or increasing. Now, I want you to use the CAGR formula and the RRI formula to figure out if you had this amount of money in 2011 in Adidas in a market value, and at 2015, this is what it was. What was your average annual percentage growth rate or investment return using both the CAGR formula and the RRI formula? So equals, double quotes, our ending value divided by our beginning value to the power of 1 divided by our number of periods. And so far, in everything we've done in this assignment has been 4 periods. And then close it out, minus 1. And we see that it's 6.15%. And I can copy that down, that if you invested in Adidas, your average rate of return would have been 6.15% compounded each year. And had you invested in Google during that same time period, you would have made 18.42%. Now we're going to do the same thing using the RRI formula. So equals RRI. Bring in my function. It's asking my number of periods. 4. It's asking for my present value, which is my beginning value. My ending value, FV is future value, return, and we should get the exact same number. Now, for your on your own assignment, I want you to figure out what the inflation rate was starting in 2018 going to 2022. This is the actual inflation rate that happened over this time period, starting from 2018 to ending in 2022, of a product that cost $100 in 2018. At the end of 2022, that same item that cost $100 now costs $120.21. And I want you to figure out what the inflation rate was using the CAGR and the RRI formula. And now, after that, you have one more thing, and what we want to do is project into the future. So let me come down here, okay, and assuming that the last 2 years' inflation rate remain constant for the next year. So we're looking at the inflation rate of 2021 and 2022. Remain constant. Calculate what that $100 item would be. That was $100 in 2018. Project what it would be in 2023. So to give you a little bit more information, figuring out the last 2 years' inflation rate is 2 periods, which means we have to use 3 years. So you can either use this CAGR formula or the RRI function and project the price. So it's a 2-step process. You have to figure out what the inflation rate was the last 2 years, and then you have to add that to the cost of the item to figure out what that item would now cost in 2023. For the year 2023, we're way past 2023. Okay, so this is your on your own right here, and that's a 2-step process. Okay, well, we went over everything. You should be able to do this on your own assignment in this 2-step process. Good luck. Looking forward to seeing what your answers are for this 2023. Thank you very much.